is Daniel Bowers. I'm part of the HP development team for Blade servers. And I thought we'd turn a conversation I was having today into a bit of a podcast. I was joined today by Brad Graham, who's also from HP, and Sylvie Kadivar, who is from Samsung. And we're going to talk a little bit about memory. Sylvie's going to let us in on some of the recent things Samsung has been doing around DRAM. And then Brad had some pretty surprising data on memory use in servers. And we're also going to take a peek into the future of memory. First, before we start off, Brad, what is your role with HP?
Yeah, hey Dan, I'm the worldwide product marketing manager for memory that supports our ProLiant branded servers.
And Sylvie, thanks for joining us. What's your role with Samsung?
I'm on the strategic marketing for DRAM, and I've been focusing mainly on our new releases, which we call the Samsung Green DDR3 solution.
Cool. I had a little incident recently that I wanted to share with you two guys. I was actually talking to a guy who does video shoots and video processing around here, and while we were talking, he found out that I worked on the HP development team for servers, and he reached onto his desk and fetched out this stack of papers. They were printouts from some websites, and they were talking about memory configurations. And he said he was actually trying to buy some new equipment to run some video processing software, and he was struggling with configuring the equipment that he was going to need. Software vendor had recommendations. He was looking at the website, HP website, some blogs. He had all kinds of recommendations, but he was really mystified by this stack of paper describing what he might need or could use around memory. And he said something like, in the past, I never had to worry about memory. When I bought equipment, I just bought the equipment. What gives? Has memory changed that much? And it kind of struck me as odd that, yeah, it has. Things have changed. It used to be, like for a server guy, memory was just DIMMs. You got some and you're good to go. But then consolidation took off, virtualization took off, and recently there's been this focus on power efficiency, and processor technology itself has changed to the point where the simple things like selecting the memory to use in a server, selecting the type and the amount, that really, really does matter. But going back to like 10 years ago, that wasn't the case. 10 years ago, we were, Brad, using 512 megabyte DIMMs?
Right. And actually, if you look back, say, in the last 3 years, I mean, our average gigabyte per server was less than 6 gigabytes. And today, if we look across all of our servers, we're looking at about 30 gigabytes per server, which is amazing. But what's surprising, though, is if you look in different segments, and to your point earlier about complexity of what kind of memory or how much memory to choose, I mean, it varies on application. For virtualization, for example, a lot of our customers are configuring with 96 gigabytes per server. Or for database customers, we're looking at, 256 gigabytes per server. So it varies, and there's a lot of information out there that's mind-boggling.
And Brad, along that line, if I may add, is that we're even seeing from measurements that we've done that in a simple configuration, for example, of a 48 gigabyte server, already the previous generations were showing that the contribution of memory in terms of the total power consumption of that system was about 26%, as opposed to the CPU that was 20%. This is actually a measurement that Samsung had done in a server configuration where it was 8 hours active and 16 hours idle. So along the line of what you're saying, where we're talking about much higher levels of density, there's a compounding effect. And obviously, the optimization of memory becomes a critical mass in terms of the power efficiency, especially when we're looking, and Brad, I'm sure you can confirm this, is that some of the IDC reports were also talking about how the energy expense has come up to the levels of about $32 billion last year.
If you look at the overall energy expense that customers are paying for energy, and you compare that to the overall server revenue spend, which was about $42 billion in 2009, energy consumption in general is significant.
So just talking about memory, I've seen some changes and some new stuff out of Samsung recently talking about new higher density DRAM, 40 nanometer class technology and stuff like that, even LV DIMMs, these low voltage DIMMs. In the past, these are relatively new things. Sylvie, what's been the driving force in the background behind that, and what are some of these new technologies that we've been coming out with over the past couple of years?
The driving force is actually coming from two angles. The first angle is obviously the chipset, the CPU. that is driving lower voltages, and with a higher performance that is integrated into these CPUs, there's a need also to adapt the memory technology that complements that solution. So there's that angle that comes into it, and today, as you know, with most of the platforms, whether it's Intel-based or AMD-based, DDR3 is the technology that's going into the server space. The other factor that comes in is the growing need for energy efficiency and power saving, as well as boosting the performance. So putting that all together, indeed, it has driven the development of what we call the DDR3 technology at 1.35 volts. Now, from Samsung's perspective, we have since last year been providing solutions which we call the 40 nanometer class green DDR3 solution. And why is it called the 40 nanometer class green DDR3? Because compared to the previous generation of memory, simply the DDR2 FBDIMM, we're talking about 78% power saving at DIMM level. Some of the studies that we've done has shown that 78% power saving results into a significant amount of power saving at the system level that can go up to 40%, if not more. And in fact, Brad, if you would like to also, from your perspective, with the HP solutions that are leveraging this technology, comment on it, it would be great.
Yeah, that's a great example that you bring up there, specifically on the 48 gigabytes of memory using DDR2. We saw about a 26% power related to memory consumption, but by leveraging low voltage memory, that actual power consumption as a percentage of total power for a server is closer to 10%. So it's a dramatic amount of savings in power and memory power footprint for our ProLiant servers. So not only that, if you look at our BL460C G7 product that we launched in June, we've doubled the number of DIMMs from 8 to 16 from a previous generation. And even though we've doubled the number of DIMMs, by using low voltage memory, we're able to reduce the memory power footprint in half. So it's really significant both in terms of being able to extend your data center capacity as well as achieve a significant amount of power savings.
So some of those power-saving numbers are pretty impressive, and they certainly pop out at you when you're considering, especially new data centers. 78% power savings DIMM to DIMM, 40% power savings at a system level. So, Brad, I assume that the 40 nanometer-based green DDR3 DIMMs that Sylvie's talking about is something that's available on HP ProLiant servers, both the AMD side and Intel-based servers.
Yes, we did launch those back in March in both the 4 gigabyte and 8 gigabyte capacities, and they're available in the Intel and AMD platforms. In terms of the overall price premium, the ILP price premium that we're offering them is at 10%, and what that works out to be in terms of dollars per watt is about a little over $4 per watt premium. But in terms of what a customer actually has to pay in terms of building out new data center capacity, it pales in comparisons. I mean, some of our customers that we've talked to are paying well over $30 per watt to build out additional data center capacity. So in terms of the overall CapEx savings, low voltage memory is a really compelling story.
Dan, we actually also did a study along that line